Now, if you think back, we had our basic two-stock portfolio formulas. So if we've got pi1 in x1 and pi2 in x2, the portfolio return is just pi1 x1 plus pi2 x2. We know that means add, so the portfolio mean is pi1 ex1 and pi2 ex2 should be added to that. Variances don't add, though. So portfolio variance is pi1 squared variance of x1 plus pi2 squared variance of x2. And then we have the covariance term, which is 2 pi1 pi2 covariance of x1 and x2. We're going to be using those today. Now, some key ideas. First one is that independent risks can be diversified away. Now, when we talk about independent risks, there are a number of things they're called. We're going to usually call them unique risks. Okay, they're unique to the firm. They're something that's independent of what's happening in the economy. So like a plant breakdown, or the CEO dies, or something like that. You'll also hear this kind of risk called diversifiable and non-systematic. And what we saw last time is that what determines portfolio risk is covariances. And those covariances and the underlying portfolio risk that they lead to, we're going to refer to as market risk. You also hear it called non-diversifiable risk and systematic risk. We saw last time at the end, if you've got an n-stock portfolio, that the portfolio variance, if you equally weight them, is 1 over n times the average variance plus 1 minus 1 over n times the average covariance. If n is big, the variance term drops out, and we're just left with the average covariance. And that's the market risk, essentially. Any questions up to there, where we got last time? Now, another way of thinking about portfolio risk is what happens as we add more and more securities into a portfolio. Let's start out by thinking about what happens then. So what we're going to do is we're going to plot the standard deviation of the portfolio against the number of stocks that it contains. If you just have one stock, let's suppose they're randomly chosen, you're going to have some unique risk and some market risk. Now, as you add more and more stocks, the unique risk gets diversified away, and what you end up with is the market risk. So this is the unique risk, and this is the market risk. Now, one important issue is how many stocks do you need before you've got rid of most of the unique risk. That number used to be about 20, but with the increase in globalization and so forth, stocks tend to have become more correlated and less independent. And today you need about 50 stocks, 50 randomly chosen stocks, roughly speaking, to get rid of most of the unique risk. Now, if you have got rid of most of the unique risk, we say that you have a well-diversified portfolio. Now, if you keep on adding stocks, there eventually comes a point where you run out of stocks because you've got all the stocks that are out there in the portfolio. Now, we're going to call that M, which is the market portfolio. And M is value weighted. So, what does that mean? Well, if the value of firm 1, the value of its stock, is $50 billion, and let's suppose that the total market capitalization, so the sum of all the stocks' value, is $10 trillion, then Pi 1, the proportion invested in stock 1, is 50 billion over 10 trillion. If stock 2 has an aggregate value of 90 billion, then Pi 2 would be 90 billion over 10 trillion. So we're just value weighting. It's the proportion of the value of the stock to the total market, which determines the proportion in M. One linguistic note. When we say trillion in the US, it means 1,000 billion. Now, in some places in the world, 1,000 billion is not called a trillion. Trillion means something else. But when I use the word trillion, I mean 1,000 billion. Now, you may think, well, that's strange that you're mentioning that, but we had an exam once where there are a lot of questions about what exactly is a trillion? How many zeros are there? So the answer is 1,000 billion. And 12 zeros, so you have, yes, 12. Okay. Now, this M is an important portfolio because what we've done there is diversify away as much risk as possible because we've got all the stocks in there. And it turns out that our measure of market risk that we're going to be interested in is defined relative to M. That measure of market risk is beta, which we've talked about a number of times by now. And if you remember, the definition of beta is that it's the covariance of the stock with the market divided by the variance of the market. And we can also write that, of course, in the form the covariance of X with M divided by the standard deviation of the market squared. Now, it doesn't have to be just a stock. It could be a portfolio. It could be an asset. It could be anything that X is referring to. But that's the definition of the beta. Are there any questions on any of that? Now, we mentioned well-diversified portfolios. And as explained, what that means is that you've got rid of pretty much all the unique risk. Now, if you've done that, what are you left with? You got rid of all the unique, so you're just left with what? Market risks. So what's the correlation between a well-diversified portfolio and the market portfolio? 1, because the unique risk is all gone, pretty much. So we're going to have that the correlation of a well-diversified portfolio with the market, M, is approximately 1. You remember what the definition of a correlation is? It's the covariance of this well-diversified portfolio with the market divided by what? Standard deviation of the portfolio and the market times the standard deviation of the market. Okay, so let's take this to be an equality. Then what we know is that the standard deviation of a well-diversified portfolio is going to be equal to the covariance of that portfolio with the market divided by the standard deviation of the market. What does this look a lot like? Looks a lot like a beta. The only difference is that with a beta, this is squared. So let's multiply top and bottom by SDM, standard deviation of the market. Then what we've got is that the standard deviation of a well-diversified portfolio is its beta times the standard deviation of the market. And that's the first important insight, and the first reason that beta is such a useful measure. We can go straight from beta to the riskiness of the portfolio by just multiplying by the scaling factor the standard deviation of the market. Now, we're always going to argue that you should work with well-diversified portfolios because you want to get rid of all the unique risk. It doesn't cost you anything to do it. It's a good idea to do it. Yeah.
Can you never diversify market risk away, not even with like the stocks with negative beta?
So if you have a negative beta stock, then you can lower it, but that's not really diversification so much as taking a position which is reducing market risk. So one way to get a negative beta, for example, is to short something. And if you do that, you can indeed bring the beta down, but it's not getting rid of it for free because you're having to short the stock. Other questions? Now, the other thing that turns out to be very useful about betas is that they add. And what we mean by that is that the beta of a portfolio is the weighted average of the betas of the stocks that make up the portfolio. And the weights in the calculation are the weights in the portfolio. So we can write that as sigma I equals 1 to n pi I beta I. If you want to see the derivation of that, it's at the end of the section. And it shows why that holds. But basically, it's the structure of the covariance formula. So now we can substitute in the beta of a portfolio, and what we get is that the standard deviation of a well-diversified portfolio is sigma pi I beta I times the standard deviation of the market. So we think back to our diagram here. What we've got now is that what each stock is contributing to the risk of a well-diversified portfolio depends on its beta. The higher the beta, the more risk that it contributes to the well-diversified portfolio. So for stock 1, for example, what we've got is that is pi 1 beta 1 times the standard deviation of the market. Stock 2 is pi 2 beta 2 times the standard deviation of the market, and so on for all the other stocks. So beta has this very nice property that we can go directly from betas to the riskiness of the portfolio by summing them up. So this is our measure of risk that adds, and that's why it's such a useful one. Are there any questions about that?